Okay, there are two different, again, system. One is the mechanical notching tool. This is a mechanical notching tool, okay? And even there is the laser notching tool, okay? You can find some video on YouTube. Unfortunately, here the link doesn't work. Okay, we can start to compare mechanical notching with the laser notching. First of all, the material speed for both is high. I mean, with both solutions, you can achieve the top performance. In the last year, with laser notching, the equipment maker were able to achieve higher performance, okay? But the performance in terms of material linear speed depends on the electrode thickness, okay? Because it's the same as for slitting that we mentioned this morning, okay? If my electrode is 100 micron thick or 200 micron thick, and I have available just this power of laser source that is 1 kilowatt, I can run faster with the 100 micron thickness electrode, and slower. I need to run slower with 200 micron thickness electrode because I need more time to cut. I need to put more energy in that area to achieve the same cutting quality. In terms of cutting accuracy, for sure the best solution is the mechanical notching. The laser notching has the problem of the reflection of metal foil and even the heat affected zone. And again, for very thick electrode, it's not easy to achieve a good cutting quality in terms of burrs, in terms of particles, okay? In terms of maintenance effort, I mean, the mechanical notching needs a lot of effort in terms of maintenance. The working life of a notching tool is around 2 million cycles, okay? That it's not a lot, it's about 3-4 days in mass production. For laser notching, there's no maintenance, okay? At least for the laser unit. For the lens, maybe yes, if the design of a particle and suction system is not good enough, so the lens can become dirty in very short time, but it's just a matter to clean the lens or even replace them. The effort is absolutely not comparable with the mechanical notching. Cutting system cost. The capital investment is very high for the laser unit. We're talking about from 100,000 to 200,000. For mechanical notching is about from 50,000 to 60,000, more or less. Depends on the dimension of the notching tool and the format size of the battery. But in terms of OPEX, in terms of operational costs, operational expenses, since the mechanical notching need to be reworked every 5 days, and after 20 cycles of reworking need to be replaced completely, you need to purchase many notching tools for one machine. So at the end, the cost will be quite the same, okay, between mechanical notching and laser notching. Only in this way you are able to keep the machine in production, okay, 24/7. In terms of flexibility, there's no story. Laser notching is very flexible since there is a scanner head, a galvo head with mirrors that can change the cutting pattern as we want. Just is a matter to program the pattern. For mechanical notching, once you have that notching tool with that shape, with that cutting shape and so on, you cannot modify. You can modify something about some millimeters, 1-2 millimeters maximum, depends on the notching tools, but yeah, at the end is very rigid, design. So especially for pilot line and so on, where the design is change continuously, is not the best solution. Move to mechanical notching. To the other side, it could be the best solution because it requires less maintenance effort. And in mass production, it's not needed to change the design so often. For example, usually in mass production, the production line are dedicated to one product, so one format size. The problem is that running at 24/7, the battery maker need to purchase many notching tool, okay, to keep running the machine. Regarding the notching defects, okay, on the left side here, you can find a quite perfect cutting quality, okay? So here in the center, you can find the white layer is the copper. On the top is the graphite coating. On the bottom is graphite coating, so it's an anode. It's quite perfect cutting quality because there's no cutting burrs, as you can see here. You cannot see any cutting burrs. There's no any evidence of the coating, okay? And there's no particles on the bottom and the top side of the samples, okay? That means that the quality of the cutting is very good. In this case, is always anode, okay? But here you can see a decoating effect, okay? So you can see that here is missing the coating. This is called the coating. This exposes the metal foil that can bend, that make some wrinkles or whatever, and then break the separator and create a short circuit. Then we need to consider that if we don't have the coating here, this amount of coating should be somewhere else. And we need to understand where, okay? Maybe it's on the electrode, so will be inside the cell, and this can create some problems in terms of short circuit. So it's very important to analyze the sample, okay, after notching and cutting process, not just in cross section, but even from the top and bottom side. Then this should be these are mechanical cutting. These are cutting burrs, okay. As you can see here, the profile of aluminum foil is a cathode, okay. So coating on top side, aluminum, and then coating on bottom side. This is wrong, it's not anode, it's cathode. Yeah, as you can see, the cutting line is not straight, it's not smooth. These are burrs, okay, cutting burrs. And as you can see here, there are some white particles. Particle that comes from the laser process. This kind of picture in cross section is very typical of a sample cut by laser, okay. And for example, this could be a defects, okay, because the cutting burst entity and dimension is too big, okay, compared to the standard specification. And in order to correct this failure, in order to adjust the quality, the customer need to focus on the battery maker need to focus on many parameters or many things. One could be keep the material more stable, okay, below the scanner head. Change the beam speed, so the cutting speed. Maybe this sample, the material require more energy, okay, or more, so decrease the beam speed or increase the pulse rate in order to remove the bars. Or change the dimension of the beam spot, okay. In this way, you have a different energy density of laser beam or your laser spot, and this for sure have a different effect on the material. So it's not easy when we talk about the laser cutting process, define what is the root cause, but we need to consider all the variables in the system.